Let's try another examples for the implicit differentiations. For the function here, due to the power of function y, it is difficult to separate y on one side and x on the other side. This makes the function here to become implicit. To differentiate these functions, we will differentiate the entire equations term by terms for the both sides of the equations. For differentiations to the functions of x, it will be d dx. Differentiating the first term will give you 6x. The second term will give you this, and incorporate dy dx. Differentiating the third term will give you -5, and differentiating y you will get dy dx. The 2 here is a constant. Differentiate to the x, you will get 0. From here, you will get these equations. You may rearrange the equation here by grouping dy dx on the one side and the others on the other side. This will give you the answer here. If you wish to differentiate further from here, this is again an implicit function, which is in the form of divisions. You may use the product rule to solve it. As for these examples, you are only required to differentiate once. Let us try another example. This is the functions. You are asked to determine dy dx. The examples are rewrite here, and to differentiate this, you have to differentiate every single term on the both sides of the equations. Differentiate the first term, second term, and the fourth term. You will get this. As number 2 here and 0 is a constant, differentiating them will ultimately lead to 0. And when you encounter differentiations of the function y, remember to incorporate dy dx. This gives you this equation here. You may reorganize the equations. Extract dy per dx out of the functions. Reorganize the equations, you get the dy dx equals to this. Next, we try this function, x squared plus y squared equals to 25. You are asked to determine dy dx when x is equals to 4. To solve this, you will have to differentiate every single term here. Differentiate the first term, second term, and the constant number. When differentiating dy, remember to incorporate dy per dx. Rearrange the equations, you get dy dx equals to -x per y. Now we have obtained dy dx. The question would like to have dy dx when x is equals to 4. From the dy dx as obtained, we require x and y. Knowing the x is equals to 4, we need to determine the y. This can be obtained from the equations x squared plus y squared equals to 25. Substitute x equals to 4 into the equation here. You will get y equals to plus minus 3. The plus minus here appear after you square root the remaining of this 25 minus 16, which is equals to 9. The square of minus 3 and plus 3 both will give you the 9. Therefore, the plus minus 3 will be adopted. From there, we know that when x is equals to 4, there will be 2 points, where 4 and 3 and 4 and negative 3. Substitute the x and y into the equations of dy dx, you obtain negative 4 per 3. Substitute x and y here into the equations, you will get 4 out of 3. With that, this problem has been solved.